And welcome to the review on trigonometry. One acronym you probably ought to remember is the famous SOHCAHTOA. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. We can begin with a 90-degree triangle, right angle triangle that is, and the opposite side is whatever is opposite angle theta, the angle we're interested in that is. The adjacent is whatever is adjoined to angle theta, and the hypotenuse would be the longest side of a right angle triangle. So we can write out the three ratios here. Sine equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tangent equals opposite over adjacent. And that is, what we remember as SOHCAHTOA. You remember that. Hopefully those ratios will come back to mind. And this is good for any right angle triangle, but of course it's good for all angles on the unit circle. Theta, that circle with a line through the middle, is called theta. That's the angle. That stands for the angle we use to measure an angle with. The units are either in degrees or in radians. And it might be useful just to define what radians are. Now, what is 1 radian? Well, 1 radian would be the angle being the same number as the arc length of a circle if the radius was equal to 1. But really, it could be any angle. If I extend my arm and sweep out an arc length equal to the length of my arm, I've swept out an angle of exactly 1 radian. Pi radians is 3.141 radians approximately, and that approximates to 180 degrees. 2 pi radians is 1 trip around the circle, or 360 degrees. Pi over 2 radians, half pi radians, is 90 degrees. Pi over 4 radians is 45 degrees. Pi over 3 radians is 60 degrees, or 1/3 of 180. Pi over 6 radians is 30 degrees, or 1/6 of 180. Notice that the general formula for converting any angle in radians to any angle in degrees is to simply take its radian measure and multiply by the ratio 180 over pi, and you'll get the degree measure. The main angles, the angles that we're mostly concerned about when we're doing measures in radians based on primary angles, are the angles 0 degrees, 30 degrees, which is pi over 6, 45 degrees, pi over 4, 60 degrees, which is pi over 3, 90 degrees, which is pi over 2, and then 180, which is pi, 270, 3 pi over 2, and 360. But it's the first 5 that really concern us, because if we can work out our angles based on these first 5, known as the primary angles, then we can, by knowing what quadrant we're in, what quadrant the angle really is in, we can work out whether that ratio is negative or positive, and that's all we need to work out. Well, let's say that we have, let's work with theta in degrees for now. And let's make a table: sine theta, cos theta, and tan theta. And let's just divide the table up into the 3 rows according to the trig ratio that they happen to be associated with. And let's now write in across the table row marked sine the numbers 0, 1, 2, 3, and 4 respectively. divide everything by 4, and then take the square root of everything. What is the result is the correct ratio, the correct trigonometric ratio for sine, cosine, and tangent respectively. Here we have the ones that all have to do with sine. The one at 30 degrees, the sine of 30 degrees ought to be 1/2, not 1 over root 2. 1 over root 2 is the sine of 45 degrees, which also translates to root 2 over 2. For cosine theta, we can write the numbers in reverse. 4, 3, 2, 1, 0. Divide everything by 4, just like we did before. And then take the square root of everything. And that gets us 1. That gets us root 3 over 2. That gets us root 2 over 2. This gets us 1/2, the cosine of 60, 1/2, the cosine of 90. The cosine of 90 ought to be 0. There, I caught my error for the sine of 30 degrees. Now 0 over 4, I forgot to put a square root over it, but it doesn't matter since 0 over 4 is 0 anyway. Now for tan of theta, all we need to do is take the sine of theta and divide it by the cos of theta. So for 0 degrees, all we need to do is divide 0 by 1. Well, that's 0. 1/2 divided by root 3 over 2 for 30 degrees is root 3 over 3. 45 degrees is root 2 over 2 divided by itself, which is 1. 60 degrees is root 3 over 2 divided by 1/2. Well, that's nothing more than root 3. That's because the 2's cancel, and we're left with root 3 over 1. And as for 90 degrees, the tangent of 90 degrees is undefined, and on the graph, this is shown as an asymptote. And that's because we're dividing 1 by 0. Now if we draw a Cartesian plane with x and y, and let's say that I draw myself an angle, and maybe that angle is somewhere in the second quadrant, and the terminal side is like this. We'll call that angle theta. The side that the angle is drawn from, which would be the positive x-axis, is called the initial side. The side that we're measuring the angle to is called the terminal side, and that would make an angle in standard position. Let's see if we can now do this for the same situation, except we're now going to go one trip around the circle as we're doing here in red, and we're going to call that angle beta. Notice that we begin on the same initial side and we end on the same terminal side. The only exception is that we're going one extra trip around the circle. But angle beta is still an angle, and it happens to be coterminal with pi. The sine, cosine, and tangent ratios will be exactly the same. So beta, which is coterminal with theta, shares the same terminal side.